Grade 10s, we're going to be looking at solving with roots today, and I'm going to be using the word roots in two different ways, so I hope that I'm not confusing you too much. But I am asking for number one, for us to solve. And when we say solve in math, we're really looking for x equals something. Well, that's the same thing as find x-intercepts or find roots. It's all the same thing. So when I look at x squared minus 36, I know a number of things. Number one, I know that if this were a parabola, it would be in standard form. So I know that the y-intercept, whoops, didn't draw that very well. The y-intercept would be negative 36. I know that it opens upwards with a regular step pattern. So I know basically this thing looks like this. So I know that there will be two x-intercepts, two solutions for this problem. I also know that that's a difference of squares. So I could factor it, and I could write it as x plus 6, x minus 6 equals 0. And say, haha, just as I thought, I have two x-intercepts. One of them's at negative 6 and the other is at 6. But I can also look at that thing and say, well, I know about solving from grade 9, and I know if I do the same thing to both sides, as long as I'm careful, I should get an answer. So if I decide instead to use roots, as in square roots, I can add 36 to both sides and say, okay, that is true for this equation. Can I get my answer? Sure. I've got to take the square root of both sides. But we need to remember that 6 squared is 36, but so is negative 6 squared 36. So if I'm imposing a square root, I need to remember that there might be two possible answers. The positive square root of 36, which is 6, or the negative square root, or sorry, yes, the negative of the square root of 36, which is negative 6. Because if I take negative 6 and square it, I will also get 36. So there's a different way of solving this problem. I know for some parabolas, the x-intercepts are ugly. So it is not very nicely factorable. So I look at this thing and see 3 and 25 and think, I don't think it's going to be very pretty. So I'm going to use my understanding of roots to solve it. So I'm going to divide both sides by 3 and then say, yep, I can do that. I can take the square root as long as I remember that there are two possibilities for this thing. The positive square root of 25 thirds or the negative square root of 25 thirds. Which if I were graphing this thing, I would be tempted to use my calculator and just find it as an approximate decimal. So the positive one would be approximately 2.9, and the other root, or x-intercept, or solution, would be approximately negative 2.9. Now they start to get wild. I'm looking at this vertex form, and if I want to find the x-intercepts, or the solution, or the roots, sorry, that is really messy. Vertex form is a problem. If I want to find x-intercepts easily, it's best in factored form. But going from vertex form to factored form takes me a couple of steps. I would have to go to standard and then to factor it. Not everything is nicely factorable because some things have ugly x-intercepts. So my decision for this one to find x-intercepts is to use roots. So for x-intercepts, this parabola is 0. I am going to get x by itself, and remember that if I impose a square root, I need to think of the positive or negative possibility. So if I want to get x by itself, I'm trying to get him alone. I'm going to get rid of all the outside stuff first. So it's like I'm doing reverse BEDMAS. I'm going to get rid of the add-ons. I'm going to get rid of subtract 8 by adding 8. If I want to get x by itself, I'm going to get rid of that times 2, and I would be left with 4. If I want to get rid of the next thing that's in the way is that square. I need to take the square root of both sides, but I need to remember that there is a positive answer and a negative answer that's possible. Square root of 4 happens to be very nice. It's 2. Lastly, I need to add 2 to both sides to get x by itself. If I add 2, whoops, I'm going to have positive 2 add 2, and I have another solution at negative 2 add 2. So I have x equals 4 or x equals 0. Let's have a look at this parabola for a second. When I first gave you the problem, we knew what the vertex was. It was 2 to the right, down 8. So about there. I know it's a double step pattern, so it's going to go over 1 up 2, over 1 up 2. Not very neatly, but I certainly see that there are 2 x-intercepts. So I was expecting a solution. Yeah, not very neatly at all. Let me redo that. Okay, for the life of me, I can't get this smartboard to line up. But anyways, I did know that there would be 2 x-intercepts because I had a vertex below the x-axis that opened upwards and was skinny. And I ended up with 2 x-intercepts at 4 and at 0. So that is logical to me. I didn't know when I looked at the question whether the x-intercepts would be pretty or not. They are. 0 and 4 is lovely. So I could have put it in standard form by foiling and then factored it. I could have done that as step 1, step 2. But I was running a risk that it wasn't nicely factorable. For this second one, when I see 3s and 11s, I'm pretty sure I'm not going to have nice x-intercepts, not nicely factorable. So I'm going to use this root method again to find my x-intercepts. So for x-intercepts, I know the y value is 0. So I'm setting this thing equal to 0 and solving for x. And it's like I'm getting rid of the outside things first. So the first thing I'm going to do is subtract 11. Oh, add 11. I'm going to add 11 to both sides. There we go. The next thing I'm going to do is to get rid of the multiplication. So I'm going to divide both sides by negative 3. Last, I am going to take the square root of both sides, remembering that you can have a positive or negative square root. I would love for you to pause this video for a second and tell me what the square root of 11 over negative 3 is. I'll just give you a second to look at that. If you type in the square root of 11 over negative 3, your calculator will swear at you. Calculator swear is written kind of like that, but if you could hear it, it's really nasty. It does not like taking the square root of a negative number. That means that there are no x-intercepts. Well, let's see if we can just have an idea of why. On the smartboard, crooked y-axis, crooked x-axis. I have a vertex of 1 to the left, down 11. So here was my vertex, very more or less. It opens downwards, skinny. Oh, there you go. No x-intercepts at all. Let's do one more together. If I'm looking for the x-intercepts, boop, I guess you'd like to see the question, would you? X-intercepts, and I have something like that. My suspicion with the quarter and with 5s and stuff is that there won't be pretty x-intercepts. I think that I would like just a quick sketch to see if there even are any. So if I have 5 to the right, 3, 4, 5 to the right, and 5 down, there's my vertex. With the 1/4 being positive, I know that it's wide, but it opens upward. So eventually, there will be 2 x-intercepts. Okay, let's solve this, ugly or otherwise. 0 equals a quarter. X minus 5 squared, subtract 5. I want to get x by itself. I'm going to add 5 to both sides. Okay, the next thing I want to get rid of is the 1/4. You can think of it in two ways. If you want to get rid of 1/4 times something, you can multiply both sides by 4, or you can divide both sides by a quarter. Either way, you're going to get 20 equals x minus 5 squared. Now I need to impose that square root on both sides, and I need to remember that I'm thinking about the positive square root of 20 and the negative square root of 20. Lastly, I'm going to add 5 to both sides. I guess I wrote that in a different order than last time, but it doesn't matter. So I have two x-intercepts. I'm going to use a calculator for a second, just so I know what they should look like. I'm having a hard time visualizing 5 add root 20. So 5 add root 20 is about 9.5. The other x-intercept, or 5 subtract root 20, it's approximately 0.53. So I've got one, should have swooped up a little bit here. Oops. And then another one over here at 9 and a bit.